Traffic lights. Vesh cycles. Batch steps on a mixing tank. Every one of those machines does the same basic thing. It steps through a fixed routine, one step at a time. And most people build that with a wall of timers and latches. There's a far cleaner way. It is called a sequencer, and it does the whole job in just a few rungs. In this video, I will show you exactly what a PLC sequencer is, how the SQO instruction works, the file, the mask, the position, how a single trigger advances one step, and why it beats a pile of timers every time. Then we will build a small one-in ladder. Let's start with the idea. Quick note before we dig in. This is from PLC Simulator, where you can build and run this exact kind of step sequence free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now, back to the sequencer. So what is a sequencer, really? Picture any machine that runs a fixed routine. A traffic light cycles green, then amber, then red. A car wash runs soak, scrub, rinse, dry. A batch tank fills, mixes, then drains. Each step turns on a specific set of outputs. Then something, a timer, a sensor, a button, triggers the move to the next step. A sequencer captures that pattern directly. You store one row per step in a data table. Each row is the exact output pattern for that step. The sequencer parks on one row, driving those outputs. On each trigger, it steps to the next row. That is it. The logic lives in a table, not in a tangle of rungs. Now the instruction that does this. It is called SQO, sequencer output. SQO has four things you set up. First, the file. That is the data table of output patterns, one row for every step. Second, the mask. The mask decides which output bits the sequencer may touch. A 1 means it controls that bit. A 0 means leave it alone. Third, the position. That is the pointer to the current step, the row it is sitting on right now. Fourth, the length. That is simply how many steps are in the sequence. There is also a done bit that fires when the sequence wraps back to the start. And SQO has a mirror twin called SQI, sequencer input. It compares live inputs against a table to detect which step you are in. Same idea, running the other direction. Here is the loop that runs every step. A trigger arrives, usually a rising edge from a timer done bit or a sensor. That trigger increments the position by 1. The sequencer reads the pattern out of that new row in the file. It ints that pattern with a mask, so only the bits you allowed get through. And it writes the result straight to the output word. Trigger, increment. Look up, mask, right? That 5-step loop is the entire sequencer. When the position reaches the length, the done bit fires and it wraps back to step 1. So one rung, fired by one trigger, drives a whole step of your machine. Now, compare that to the old way. You can build step control with a chain of on-delay timers and a stack of set and reset latches. Step 1 latches starts a timer. The timer done bit resets step 1 and sets step 2, and on it goes. It works, but it sprawls across the program. And the moment you need to add a step or reorder them, you are rewiring the whole chain by hand. The sequencer keeps every step as a row in a data table. Adding a step is editing one row. Reordering is moving rows. It is cleaner and it scales. I have a separate video on PLC timers and another building a traffic light step sequence, both linked below. Let's make it concrete with ladder. Picture 3 rungs. Rung 1, a trigger contact, a rising edge one-shot off your timer done bit, feeds the SQO step pulse. Rung 2 is the SQO instruction itself, pointed at your output file, with your mask, your position, and your length. And rung 3 restarts the step timer for the next well. That is a complete step sequencer in 3 rungs. The data table does the heavy lifting. Each row lights the right outputs for that step. The mask guards the bits you do not own. And the position just walks down the table on every trigger. Build it once, and adding step 5 is a 1-row edit. So here's what to walk away with. A PLC sequencer steps through a data table of output patterns, 1 step per trigger. The SQO instruction is the tool, file, mask, position, length, and a done bit. Each trigger increments the position, looks up that row, masks it, and writes it to the outputs. And it beats a wall of timers and latches because the logic lives in a table you can edit. Get that, and every step-through machine on the floor stops being a mystery. Now go make it real. If you want to build and run a step sequence hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, new video every Tuesday. See you in the next one.